Hey, June.
Good afternoon, Dr. Francis.
Afternoon. How are you?
I'm fine. How are you too?
You joined us today.
Abio, finally.
Wow, that was good. So,
I'm
yeah,
able to join today.
Good afternoon, Dr. Francis.
afternoon. How are you?
Fine, thank you, sir.
Idris, how are you doing?
Good afternoon, sir. Dr. Francis, how are you, sir?
Good.
Well done, sir. Hi, Pedro. Good afternoon. How are you?
Hi, I'm good. Good afternoon. Happy Sunday.
Happy Sunday.
This one I know, but the name is still, I'm trying to recollect the case.
Do you have Python installed? Yes. Do you have Python installed on your system? Pedro, there. Pedro, are you there? Oh, sure. Love that.
Hello, Dr. Francis. Can you hear me now?
Yeah, I can hear you now.
Sorry, I actually heard you and I was trying to talk, but I think my network was unstable that time. I don't have the Python on my system more.
Hmm.
Where can I get it? How can I get it?
Just go on Google and type download Anaconda.
Anaconda, okay. Download Anaconda.
Have you watched the movie Anaconda?
Uh-huh.
I watched it a bit.
Yes.
Was the movie scary?
Yeah.
And
Okay.
so that's how it's going to
So
be.
the python will be
That's how
scary.
it's going to be scary today.
Oh,
Because you know that say
download.
we just come from outside the house into the house, everywhere will be dark, is it not?
Mm,
Mm. But with time, inside darkness, you start to see.
yeah.
Probably just watch what we are doing, but so that you understand where we are heading to. But you can be
No
downloading,
problem.
you can be downloading the software first. So just go on Google and
Yeah, I'm
type
doing that.
download
I'm doing
and
that now.
You have informed that we are about to start starting now. So we have a lot to cover.
Okay, sir.
Mhm.
We could start now and then others will join along the way.
Okay, they will join. Okay. Probably I'll just be doing revision from what we did last week.
All right, sir.
Mhm.
Thank you. Page have you installed now? We're still installing.
I think I'm almost there. Oh, okay, you're sharing screen. I wanted to show you what I am seeing, but I don't
Okay, sure. Let us see.
know. I saw this. Can you see my screen?
But if they could come down, let me see.
I put the code. I got the code in my email,
Or they give you a code.
and yeah, I sent the code to my email,
And you put,
which I put. I mean,
did you verify that?
yes, but
But normally,
okay, another mail has.
you don't normally send code. You enter it as lesson, but have you entered it?
Okay, I want to enter it now. That's the code.
Otherwise, I'm supposed to just download it straight for you.
So I don't know. It keeps saying this already completed something something. I don't know why.
Just go
The
to
verification code is
Google.
invalid. Oh,
Just go to your Google. No, just type
okay. I
Google
should go to Google.
for search engine.
Okay.
Just type Google. So type this thing. Now let's check. Download an account. Let me see what's coming up.
Yeah.
I have download.
This right?
Yes. Yeah, search. Let me see.
This free download, right? Is it a free download?
You fit down, but come down and let me
Can you
see.
see what's on my screen?
Yeah, I can see what's on your screen. Come down and let me see.
You said?
The same thing now. So click on that third one. Let me see. Click on that third one.
This one.
On the third one, let me see where you have Anaconda, world most popular data science platform. Yeah, click on that one. Let me see.
Yes, I've
Yeah.
clicked it. I've
Yeah.
clicked it. It's coming. Yeah.
You can see free download on the corner, right?
Yes, the same thing I did.
So that was what you
Free
did.
download.
So why is it going to?
Yeah, I did that before.
But it's still look at now, you're still downloading now. It has not finished now.
Okay.
Can you see it on your?
Okay, I think, but I can see free download. Yeah,
No, don't
by
look.
the
Can you see
right.
that? Can you see that square blue? This thing on your that blue ribbon on your right, where you have your downloads. No, go up. You see it up there. You see like it's downloading
This
something.
one. Yeah, yeah,
Yes,
It's downloading.
yeah,
Yeah.
it's downloading now. So that sign up, you don't really need it.
Okay.
You get you don't need. So once you just finish, you can just start.
All right.
All
Thank
right.
you.
So let me just do revision of what we did last week. Why others are joining us. Okay. Good afternoon, everyone.
Good afternoon, sir.
Good afternoon. Okay. So far we have started with what machine was learning, right? What do we say machine learning is about? What did you say machine learning is about? Yes? Hello.
Hello, sir.
Yeah.
Okay, so I think it's something about the computer or a software
Mm.
like learning from human behavior and trying to improve on on the efficiency of capturing that data and using it to project basically or to forecast.
Yeah.
Yeah.
So normally, human beings, right? You learn from your experience, right? They learn from experience. Okay. But computers, what we call machine, learns from what? Data. Isn't it? So which means for you to create a machine learning model, you must first of all have data, isn't it? And that's why we see that it is from this data the computer what learns, right? And how does it learn? Through an algorithm, which we tend to build in form of a model. We build the model and apply the algorithm, which is now going to learn. And based on its learning experience, it's now going to do its what? Prediction. And we try to distinguish between prediction and forecasting, right? Do we distinguish between prediction and forecasting in machine learning? Did we distinguish them? Prediction and forecasting?
Yes, we did.
We
Good
did.
afternoon, everyone. We
Okay,
did.
so what do you say is the difference between the forecast and prediction?
We said forecasting is data over a period of time,
Yes.
while prediction is data collected at a point in time.
So most times when you are doing a time series analysis, right? Once it's time series, what you're actually going to be doing is what? Forecast. But when it's a cross-sectional data, what you normally do is what? Prediction. Okay, it's prediction. All right, good. And it's based on this prediction that we have done, they now what? Deploy it. Right? They can now what? Deploy it. So subsequently, anytime any data now comes in, automatically it picks it up and does a prediction or make a decision for you. Okay. So this development of your machine learning is what is now regarded as what? AI, artificial intelligence. Okay. That's why we say that machine learning is a subset of what? AI. Okay. It's a subset of what? AI. Because at the end of the day, just the same way we make decisions, we want the computer to also assist us in making decisions. Okay. So your machine learning is what? A subset of what? Your AI. All right. Now we said that under machine learning, we can classify them basically into two. What are they? What are they? So machine learning, we can classify them into two. What are they?
Supervised and unsupervised.
The supervised machine learning and what? Unsupervised machine learning, right? Good. Now we started by looking at supervised machine learning. Okay. And we said that under supervised machine learning, What do we do here under supervised machine learning? So under supervised machine learning, what do we have there? Yes, under supervised machine learning, what do we have there?
Labels.
We have what? So we have what?
Labels. We have labels.
We have labels, right?
Yes.
Usually what labels, okay? That means specifically we are telling it, we are supervising the data and saying this is good, this is bad, or we just give it what whatever distinction or instruction we need. Okay, good. So under supervised machine learning, when we say labels, remember from our model, when we build our model, what is our Y? What is our Y?
Dependent variable.
Yes, which is also called what?
Target.
No, target, your target. What you are trying to what predict, your target. Why your X is called what?
Your independent variable.
Or what?
Picture.
Features, or features.
Features, yeah.
In statistics, we'll call it dependent and independent variable. In practice, they will either call it target or outcome variable. Outcome variable. Why these are what features or what we call your predictors. Okay. So features and targets. Good. Now we said that when we look at our data, remember we explained it. We talked about variables. And what do we say variable is? What do you say is a variable? Yes, what do you say is a variable? A variable. What is a variable? Data analyst. What is a variable?
The container of
A what?
Indicators.
can be used to store, so it can be used to present information and it changes, it's not fixed.
Okay. All right. So a variable, in simple terms, is anything that changes, varies. It's not variable, variation, it varies. Right? It varies. But from a programming point, you say a variable is a container, is it not, that can store anything. But this, you see, it can still take any one thing. Okay. Now, from this variable, we say we can classify them into two. They can either be what? Quantitative, or they can be what? Qualitative. Right? And whichever one we choose, this variable, we need to know how to what? Measure it. We need to know how to what? Measure the variable. Okay? And in statistics, we know there are 4 levels of measurement. What are the 4 levels of measurement? What are the levels of measurement? What are the levels of measurement? Okay. So what are the levels of measurement? We want to measure.
Nominal.
Nominal, isn't it? So we have nominal. What do we have again?
Ordinal.
Ordinal.
Ordinal, okay. Ordinal, what again?
Interval.
Whereas we have interval,
Oh, yeah.
and we have what?
Ratio.
Ratio. Good. Now, you see this measure, it's a very important concept we must understand in machine learning. Because always remember, how we collect our data will determine how we are going to what analyze it. Okay? So when we talk about nominal data, what do we understand by nominal data? Nominal. When you say nominal, what does it mean?
They have no numeric weight. They
Okay.
are just descriptive and numbers.
Yes, so they just describe, they are just like names, right? Just names. Okay, they're just like names. Okay. What again, or what you call labels? They are just like names or what labels.
Is it data that can be categorized?
Aha, you can also categorize them. Yes, you can also categorize them,
Okay.
right? You can categorize them, yes. So that's why I was saying categorizing them, it means you can label them or give them names. Right?
Okay. Okay.
But most time when you want to analyze them, you cannot just use names like this. For example, in class, we can classify the people based on gender, is it not?
Yes.
Based on gender, we can have what? Male or female, is it not? So these are the example of what? Nominal, right?
Okay.
Or you can have give another example of nominal data. Give another example of a nominal data or variable.
What about
Ethnicity.
Ethnicity.
mhm.
Ethnicity, So we can have Igbo, you can have maybe Yoruba, maybe for example, let's say you can have Hausa, maybe you can have others. Can you see that? Or religion. Can you see that? Religion is another one. I hope this example is clear, right? But now what distinguishes them is that most time when you want to analyze, you cannot just leave it as male, female, right? You cannot just leave it as male or female. So what do? We now have to what? Convert them into what? Numbers. You see that? We have to now convert them into what? Numbers. So for example, male, we assign 1, female, we assign 2. You don't notice? It's just to distinguish them. But are we saying that male is better than female, or female is better than male? Can we say that?
No.
No, is it not? So in this case now, that's why somebody said they have no weight, is it not? So we are just using these numbers just for assignment purpose alone. So we cannot say whether 2 is greater than 1 or 3 is greater than. We cannot say this is 1, 2, 3, 4. Can you see that? We can't say 4 is greater than 3 or 3 is greater than 2. We are just using the numbers to assign them. So that's why they are called nominal scale. I hope this is clear. Because we are going to come back to this much later, but this is the foundation of what we are going to build on today. So I hope this is clear. Nominal, I hope this is clear.
Yes, sir.
All right, good. Now, what about ordinal? When you say ordinal.
Ordinal has an order.
There's an order, is it not?
Yes, and it can be ranked.
An order, it can be ranked. Beautiful, it can be ranked, is it not?
Yeah.
So nominal, no order, is it not? And also there's no rank. Is that not it? No other
Yeah.
rank. Good. Can we give example of ordinal? Can we give example of an ordinal variable? Ordinal.
Okay, when you are given good, very, I agree, disagree.
Okay, so for example, like ratings, is it not? Or level of satisfaction. Isn't it? So which means if they say, to what level are you satisfied with our service? Is it not? They will say excellent. Is it not? They will say very good. They will say good, neutral, or we'll just say average. Let's say average. What again can we say? Bad.
Recording in progress.
Bad. You can say very bad. Can you see that? So in this case, when we are ordering it, we can now order it 5, 4, 3, 2, 1, probably 0. All right. Good. So you see now there's an order to it, is it not? So it means excellent is better than very good. Very good is better than good. Good is better than average, right? Average is better than bad. Bad is better than very bad. I hope you understand that. So in this case, or they give you products. They give you different products. Maybe they give you product A, product B, product C. And now tell you to rank your preference. Rank your preference, right? Rank your preference. So if you are ranking, you now have to give instruction. What is the order? Is it 1 for first position? That means I prefer this 1. 2 second position, 3 last. Or 3 has a higher weight, means I prefer it. 2 lower weight, 1 the lowest weight. So how do we now order this? Now if I say give you 3 products, maybe or I say rank the mobile networks. And we now say, okay, we have MTN, we have Glo, we have Airtel, and we have 9 Mobile. Okay. And now say rank your most preferred network. Is it not? So how are we going to rank this now? How are we going to rank it? So how are we going to rank it?
MTN number 1.
So MTN number 1. So number 1, you are giving in terms of position, right?
Yeah.
Okay, 1.
Yeah.
Airtel too.
RTL number 2.
Really?
Yeah.
Yeah, so
Wow.
Number 2, okay.
Glo, then 9 Mobile.
So Glo 3 and Mobile 4, right? So based on our ranking now, so which is better? 1, right?
Yes.
1 is better than 2, 2 is better than 3, and 3 is better than 4, isn't it?
Yeah.
Good. And now people would have weighted it the other way around and now say, okay, since MTN is my best, I'll rank it 4, which means it has a higher weight. Right? Followed by what? Airtel, followed by what? Glo, followed by what? 9 Mobile. Can you see that? So you must know how you are ranking it because there must be consistency on how you're interpreting it. I hope that is clear. So that is what? Ordinal. Right? Ordinal. And take note, nominal and ordinal applies to what? Qualitative data. They apply to what? Qualitative data, or what we call categorical. I hope this is clear.
Yes, sir.
Good.
Is it quantitative or qualitative?
Qualitative.
Qualitative.
They apply only to quality. All the variables you have been given, they are all qualitative now, right?
Yeah.
Yeah.
Now, interval and ratio are applied to what? Quantitative data, or what we call numerical. Numerical. Okay. So what differentiates then your interval? So for example, this one interval ratio. Now here there's no interval, or they have a consistent interval of 1, right? But here you can have something like income level, right? Income level. And based on that income, we can now categorize them, or let's say even age. We can say between 18 to maybe 25. Between 26 to maybe 35. 36 to what? Let's say 50. And we can have above 50. Can you see that? So in that case, we can group our data, is it not? So in this place, we are having that 18 is lower than what? 26, not? One, there's an interval, and also there's another. Can you see the difference now? There's an interval, and now there's what? An order. Above 50 is greater than 36 to 50. 36 to 50 is greater than 26 to 35. 26 to 35 is greater than what? 18 to 25. So that is called what? Interval what? Ratio. Have you got that? But and that thing again, we need to
Sorry,
understand.
I still didn't get that interval ratio.
Interval now. So look at
Interval,
that
sorry.
one, right? This is age, right? You can also have income level, right? You can also have income level. So
Okay.
between maybe minimum wage rates 0 to what? 30,000. Is it not? We can
Yeah.
have 1,000 to 50,000. 50,000 to about 100,000. We now have above 100,000. Can you see that? There's an
Yeah.
interval.
Yeah.
Is it not?
Yeah.
Also, there's an order.
Yes.
You see that? So this interval applies to only quantitative data. It applies to only quantitative what? Data. Right? You cannot apply it under your qualitative or categorical. But another thing that differentiates it is how you interpret the zero. Okay? So there's no true zero. So for example, say there's no true zero. For example, temperature. Temperature, right? So if you have a temperature of, what is current temperature right now? Let's say about what? 89. What's the temperature right now in Celsius? What is temperature now?
That's
29,
degrees.
29
29 degrees Celsius.
30 what?
31
29.
degrees.
31 or 39?
31.
Okay, 31 degrees Celsius, right? So how do you interpret this? How do you interpret this weather now?
Hot.
It's hot.
It's hot, right?
Sorry.
Yeah, it's hot, right? Good. What about 16 degrees? How do you interpret it?
Oh, it's getting colder.
Getting colder. When it gets to 0, how do you interpret it?
It's not habitable.
Hmm?
No, it's no longer habitable.
Mhm. So 0, does it have a meaning?
No, you can go to
Yes,
minus.
it does.
Does it have a meaning?
Zero has a meaning.
Yes,
What
yes, it
do
has a meaning.
It's really cold.
It's
Yes.
below boiling point. A bit below
Freezing.
That's freezing.
Freezing point, right? Okay, good. So when you are seeing that, so imagine you have sales. Let's say you have sales. 0 sales. What does that mean? 0.
No sales.
It means what?
Okay.
It means what? No sale, is it not?
Yes, no sales.
So this is what is called, this is what they refer to as what? A true zero. They call it what? A true 0 points. True 0 points. Means 0 means nothing, right? That's how you interpret it. So this is under where you treat your what they call your ratio scale. Your ratio what scale. But your interval scale, this 0 has a meaning. So that's why they say no true 0. No true 0. Can you see the difference now? Under temperature, when you interpret in terms of temperature, right? 0 has a meaning, so it's not a true 0. Because normally, how we know 0? 0 means nothing, right?
Yeah.
So that's why they say has no true 0. But under your ratio scale, in addition to everything we have seen, one, there's a range, is it not? You can have an interval, there's an order, and it has what? A true 0 points. Okay? So for example, apples, how many apples did you buy? None. That's 0, is it not? That is what? A true what? 0. But in terms of things like temperature of 0 has a meaning. Is that not it? Temperature has what? A meaning. Okay?
Yes.
So that is why we say it's what? No true 0. That's just the basic difference between both of them. Right? So don't bother yourself too much about how they interpret them. Just understand that your variables, we can break them, the measures can be broken down basically into nominal, ordinal, and what? And we can just call this one scale, right? You just call them scale. Scale here can mean either interval or what? Ratio. And again, you can also divide it out and have like a proportion under your ratios. Okay? Good. So this applies to what? Qualitative data or categorical data. Why this applies to what? Quantitative data. I hope this is clear.
Yes, sir.
Please.
Can you repeat that, please?
Repeat which one?
How we refer to qualitative and quantitative. So interval is qualitative. And
Interval is what?
qualitative.
How is it qualitative?
I'm asking, I thought that was what I had.
No, man. Quantitative. 16 degrees. Is it qualitative or quantitative?
Quantitative.
Is it not? And we say quantitative falls under what? Interval.
Okay.
Because between 0 degrees and maybe how many degrees now? Should I say 20 degrees? Between 21 degrees and 30 degrees, is it not? Between 31 degrees and 40 degrees. Can you see that? There is what?
There's an
Because an interval, is it not? There's an order and there's what? No true zero. No true zero. When you say no true zero, what does it mean? No true zero, what does that mean? When you say no true zero,
It means zero
It
has
has a meaning.
that zero has what? A meaning, right?
Yeah.
Because how we know zero means nothing. Right? Good. Why for ratio scale, we say ratio scale, the same thing, that it has what? An interval, there's an order, but the zero has what? A true
Meaning.
point. So it means it has what? Meaning. Okay. And that's the again, we can also, just as they imply, we can also do ratio. Maybe 10/15, right? And zero, we can have 0.1 something, and it will still make meaning for us. And these ones apply to what? Quantitative data. While your nominal and ordinal apply to what? Qualitative data, which is also called what? Categorical.
Yeah.
Is this clear?
Yes, sir.
That's why what we have seen, that based on the variable, we will need to what? Measure it. And based on that measurement, we'll go and what? Extract what? Data. The same way, the data can be what? Qualitative or what? Quantitative. These are qualitative data, is what we refer to as what? Categorical data. And these are quantitative data are called what? Numeric data. And what do we say differentiates quantitative data from qualitative data? What's the difference between qualitative and quantitative data?
Is it their ranking?
Ranking. What differentiates qualitative from quantitative data?
One is numerical.
The weight has value.
What?
In
Quantitative is measurable. It can assign values.
But we have said it now, all of them can be measured.
Okay.
That is qualitative or quantitative data, we can measure them.
Okay.
Whether it's qualitative or we can measure them. We
Okay.
should gender, religion. Were we not able to measure it?
Yeah.
But what differentiates qualitative from quantitative data? What differentiates quantitative from qualitative?
Doesn't have order.
Apart from the order, but what's the major distinguishing feature between quantitative and qualitative?
The value of the weight.
I think in quantitative, the weights and the numbers has value.
Okay, apart from the weights, what's the other major distinguishing feature between qualitative and quantitative as an analyst? Yes.
Mathematical operations.
That what?
Mathematical operations, you can carry it out on quantitative.
On which one?
On quantitative.
On quantitative, it means I can add, I can subtract, I can divide, I can multiply, and it makes sense. But for categorical data, what do we do?
Descriptions.
Descriptions, yes. But what kind of analysis can we do for it? What kind of analysis can we do for categorical data? What kind of analysis can we do for categorical data? Yes. What kind of analysis can we do for categorical data? What kind of analysis can we do for categorical data? Yes, what kind of analysis can we do for categorical data?
I want to see frequency distribution.
Which means that what are you doing there?
Import. Like, how many times does this particular
Yes,
variable occur?
count. You're only counting,
Count, yes.
That is why when we analyze, we say value count, we do a value what count. All right. But for your quantitative data, I can add, I can subtract, I can multiply, I can divide, I can know the minimum value, I can know what the maximum value, I can know the average, I can know the median, I can do the standard deviation, and they will all make sense. Which means when we are analyzing, we are either what? Describing, we want to what? Describe. We want to what? Compare. We want to what? Find relationships. Or we want to what? Predict. Isn't that what we said when we are doing our analysis? Now, this is the same thing. So this prediction is the part we are now dealing with in machine what? Learning. But you must first of all understand how this works. Okay? And we have seen that in machine learning, we said there are two: supervised machine learning and what? Unsupervised machine learning. And we said under supervised machine learning that we have labels. Here, there are no what? Labels. And what do we mean by label? So if you build the model, y as a function of x, we have agreed now, is it not? That this y is known as what? Your target. And y your x is known as your what? Feature. Now, where this the target variable is what? Quantitative. You know, because remember, quantitative data can either be what? Discrete or what? Continuous. So where your variable is what? Quantitative, whether discrete or continuous, what machine learning algorithm do we apply here? What machine learning algorithm do we apply here? What machine learning algorithm do we apply here? When your target variable is what? Quantitative or is continuous. What algorithm do we apply here? So from that data, you are going to apply what? A model. From the data, you build the model. From that model, you now apply the algorithm. It's based on this algorithm that we can now do what? Our prediction. So now we have the data. We have built our what? Model. Now, which algorithm are we now going to what? Apply?
Linear regression.
We are going to apply what? Linear regression. We are going to apply what? Linear regression. Everybody, I hope you are clear with this. Linear what? Regression. Because that's the condition that you are going to use. Okay? And this is the foundation of all the machine learning models we have learned. Right? Any algorithm you learn, this is the foundation of it. Last week, we had run a linear regression model, isn't it? We showed how to run it in Excel already, right? We also showed how to build it in Python. So let's go back to Python and try to build it. Which data set did we use the last time? Did I share any data sets for us?
Yes, you did.
Which of them?
US.
Okay, US housing.
USA housing.
USA housing.
I don't have it.
Please, somebody should share it on
Can someone share it on the WhatsApp group?
share it on WhatsApp.
I will share it now.
Okay, you can share it here. On
Okay,
Zoom.
sir.
I think WhatsApp would be better because I'm not using.
I'll share it on both platforms.
I share it on both because not everybody's on the WhatsApp.
Thank you.
All right, so let's try and quickly run immigration. So let me try. Where's my data? Let me copy the passwords. So I hope you can see my screen.
Yes, sir.
Okay, good. So what do we need to do here now? What's the first thing we do? What's the first thing we do?
Import libraries.
Import the libraries. So which libraries are we importing? So we can say import what? NumPy as what? And import what?
Pandas.
As PDs, Then
Yes.
we need to do visualization. What do we do next? Import what? Matplotlib dot what? PyPlot as what? PLP. Probably if you want to display your chart, then you can just use the Matplotlib inline. Then another library again we can use import what? Seaborn as what? SNS. If I didn't make a mistake in my spelling. All right, good. So now we have brought in the library. So what's the next thing we do? What's the next thing we're going to do? Once we have brought in our libraries, what's the next thing?
We're going to bring in the data.
What do we bring in? We bring in the data, isn't it? So what's the data? So I can say df equals to pd dot what? Read. What kind of file is it? Is it an Excel file or a CSV file?
CSV.
The CSV file. So read CSV file. Then I'll bring in my path. Okay, good. Then df, and that is the data. Can you see that? So most time when you are working with machine learning, you cannot work with text this way. You can't work with text this way. You only work with what? Numbers. Can you see that? You only work with what? Numbers. This is now the advancement now you now see machine learning models, which has led us to what they call LLM. What is LLM? What is LLM? What is LLM? What do you mean by LLM? Yes? LLM.
Large language models.
Large language models, not which is what ChatGPT is using. So that's what your ChatGPT is using. So they are called what? Generative what? Models. So they use text. So they are mostly using what? Text. And this is a form of what? Unsupervised machine learning. What we now refer to as natural language processing under your deep learning, which is close to what? Your AI, which drives your what? AI. Okay. So what we are doing at this stage, we are not this much of this more advanced, this advanced level, right? But for now, all we are working with is still what? The supervised machine what? Learning. Okay. right? And we say under supervised machine learning, we can break them into two. What are they? What are the two types of supervised machine learning? So what are the two types of supervised machine learning? Yes, what are they? What are the supervised machine learning algorithms we have here? Yes, what are the machine learning algorithms we have here under supervised machine learning?
I think we said regression, the linear regression.
So we have regression, right? We have regression. And we have what? Classification. And we have what? Classification. Very good. So looking at this data, which machine learning algorithm are we going to apply? Looking at this data, which machine learning algorithm are we going to apply and why? Yes? Which machine learning algorithm are we going to apply and why? Hello. Which machine learning algorithm are we going to apply and why? I thought we have discussed it already now.
Yeah.
So which machine learning algorithm are we going to apply here and why?
What we have.
Yeah. Which machine learning algorithm are we applying here and why? Data analyst. Which machine learning algorithm are we applying and why? Okay, so can you tell us why? Why linear regression? Why linear regression? So why linear regression?
Because there's only one variable, one dependent variable. So one independent variable.
Okay. So one dependent variable. Is there any situation where you have more than one dependent variable? Is there any situation where we have more than one dependent variable?
Independent variables, rather. Yeah, situation we have more than one independent variable. That is the multiple regression.
Yeah, that is multiple regression, right? But we're asking, why is regression applicable in this case? Why is it applicable in this case? Why is it applicable in this case? Now let's remember that when you collect data, right, you need to understand, but remember what we said, that how you collect data will determine how you are going to analyze it, right? And we said that the moment you see, so in this data now, what is the dependent variable here? In this data, what is the dependent variable here? What is the dependent variable here? I hope we are all familiar with regression.
Yes, sir.
Or is this the first time we are hearing about regression? We also we did it last week now, isn't it?
Yes, sir.
I'm familiar with it.
Yes, you are not familiar with it.
No, I was not here yet last week.
You're not here last week.
Yeah.
So we said normally your regression is about pattern recognition, right? Pattern recognition. Okay. And we give an example when you buy or you watch a horror movie on Netflix, you know, after you finish watching the horror movie, what do you now observe?
Will you be afraid?
Huh? No, you may be afraid, that's one, but once you are done with the horror movie now, there's another thing you observe again. Netflix will not show you.
Okay,
Other
other horror movies. Or they will
Other horror movies, no. So based on what you have been watching, is it not? So it will now recommend for you.
Yes.
So those are what they call pattern recognition. That's regression.
Okay.
It's an algorithm. So that algorithm, what they refer to as what we are deploying, is called a recommender system. It recommends for you based on the patterns. Same thing when you buy on Jumia or on Amazon. If you buy a bag, a handbag, it tell you that people who bought handbag also bought, what again will you buy? Shoe. Also bought matching, what again? Matching shoe. Matching what again? Maybe bracelet or watch. So based on people who bought this, they also bought this. So it will now do also what recommend for you. So that's regression about what? Pattern what recognition. And we are now saying that the kind of regression you are going to apply now depends on the data you are collecting, right? But the first thing is that your model must be correctly what specified, you know. We must be clear which is dependent and which is independent variable. Okay. Do you understand what they say dependent and independent variable? When they say something depends on the other.
Yes.
Okay. So for example, if we say labor and productivity, which is dependent and which is independent?
The productivity is dependent on the labor.
So productivity
depends
on labor, right? So in that case, the productivity becomes what?
Yes, the independent variable.
Oh, say it again.
So productivity depends on labor.
Productivity
becomes
on labor.
Yes.
So this productivity becomes what?
Dependent variable.
Okay.
Dependent. Why your independent variable is called what?
Labor.
Labor.
It's not labor.
Yes.
Have you got that now?
Yes.
Good. So when we see y represents what? Y represents what? So
Y is the
Productivity,
dependent variable.
dependent.
call our target, is not, which is
Yes.
Yes.
as a function of what? X. What's our X?
The
Is our
future.
you know, which is
Yeah.
our what? Labor. Can you see that? So
Okay.
a problem must be correctly what specified. So from
Correct.
from theory or from observation, what are you have been observing? Why our employees leaving? Why our employees leaving us? You know, as a HR person, you can have certain what observations, or there may be a what theoretical explanation on certain reasons why people are leaving your organization. Okay, so if that comes from theory or comes from observation. All right, good. And we say that once the dependent variable here is quantitative or continuous, we can say it's continuous variable, right? We apply what they call what? The linear what? Regression. We apply what? Linear what? Regression. Daisy, do you understand this now?
Yes.
Now, though I taught this last week, but let me just expand on it further, right? Now, under regression, we don't just have only linear, but this is the foundation.
Okay.
We also have other types of regression. There's another one we call what they call ridge regression. There's another one we call lasso regression. There's another one we call elastic net regression. But they all have conditions when to use. But this is the one we normally would use. It's as a result of the problems you may encounter in this that gave rise to all these other issues in practice, right? However, but we are going to only teach linear regression for now. Subsequently, when we get a bit more advanced, I will explain this one going forward. But for now, let me try and implement a linear regression model. We have already seen how to run it in Excel now, is it not? We have seen how to run it in Excel.
Yes, sir.
Isn't it? So the same way I will try to explain it here. So the first step is to what? We have imported all our libraries, brought in the data, isn't it? And since our data, we are going to classify them into two. We have our dependents, these are our targets, and we have our features. So we are going to break the data into two parts. What we call what? The trained data, and we have what they call the test data. Whatever you do for your target, you will do for your feature. So you also break the data into two. What are they? Trained data and what? Test data. But before you normally would have started, you have first of all have cleaned up the data. You have cleaned and transformed the data. I'm not going to be focused on the cleaning at this stage now, right? When we are doing a full project, then I can do all the cleaning and all, but for now, I just want to explain the concept for us, all right? So let's continue. So the first thing I want to do, I want to break my data. So first of all, I don't need this address here, right? So let me bring it. So if I say df.columns, can you see all the columns here? So let's say I want only except my address. So I'll take all the columns except what? Address. Okay, so I can say df is equal to what? Df address. So now if I run this, can you see that this address is no longer there? Because we cannot work with text. If there was text, we need to transform it. Even some people can still get some features out of this. They can still get some features out of this. Okay? That is what they now refer to as what? Feature engineering. For now, what have we done? It's called feature selection. This is called what? Feature what? Selection. Means I'm selecting the variables I want to use. It's called feature selection. But when I create a new feature from already existing feature, it is known as what? Feature engineering. I think we explained this concept last week. Did you explain this concept last week?
Yes, sir.
Good. And remember, we said that for most of your quantitative data, we can do summary statistics. So I can say df.describe. It means I'll do what? A descriptive statistics. Can you see that? I can find the minimum, the maximum, the average, the count. Can you see that? We can do all that. All right. We can even find correlation. So df.correlate. Can you see the correlation? Good. I hope we know how to interpret minimum, maximum, average. We know how to interpret correlation, relationship. All we are looking for is whether it's positive or negative. If we see any negative sign here, it means it has what? Negative relationship. If there's no negative sign here, it means it has what? Positive relationship. Is that clear? Is that clear?
Yes.
Yes, sir.
Good.
Yes.
All right, great. So the next thing we want to do is we want to try and do a train test split, right? So I want to break the data into two parts: train data and test data. So what do we do? Now, why do we do train and test? Why do we need to do train and test? Why do we do train and test data? Why do we break it into train test and test sets? Why do we do that?
Because the train data is what we use for the machine to learn.
Okay.
We use that for learning. The machine use that to learn, and then the test data is what the machine used to predict.
Beautiful, beautiful. So if you know what predict, is it not? It's just like you are preparing for exam, is it not? The lecturer gives you what? Past questions. Based on those past questions, you go and learn, is it not? You now come and now do what? Test. Is it not? Or you do write your what? Exam. But you know that saying, example know the hard teacher. You know that saying? Example know the hard teacher, is it not?
Yeah.
Now he gives you A, B, 1 plus 1. They are shouting 2. You are seeing the question. 2 plus 2. Says wonderful. You now get to exam hall. They are now giving you 3x plus 2. You say, hey, I did not see this one in past question. But when they gave you past question, you knew all of them, is it not? Because you have what? Remembered all the answers. But when they now gave you exam, you say, hey, I did not learn this 3x plus 1. What they call that type of train is called what? Overfitting. It's called what? Overfitting. It's like you are going to cram the whole thing. If they have brought anything here, this train, you will get 100 over 100. But anything outside it, on your own, no. So that's what they call what? Overfitting. Is that clear? Do we get that? Underfitting means, underfitting means they gave you the past question. You did not read it. You could not, you didn't really prepare for it very well. So you didn't, even when they gave you small, your course will be asking you, you're not even getting them. But you go to exam hall, they are asking you 3x plus y, you are getting all of them, is it not? That kind of model is called what? Underfitting. Do you understand it? It's called what? Underfitting.
I don't understand.
Because of this problem of overfitting that led to the other what? Regression, which was what? The ridge regression, the lasso regression, and what? The elastic net regression. I hope that is clear. So it's as a result of this problem of overfitting. Because you don't want a situation where you are trying to what? Predict whether customers are going to buy the product or not, right?
Can you repeat it, sir?
What should I repeat?
The description of the problem of overfitting.
Okay, okay. But do you first of all understand what underfitting is?
No, the underfitting is even my problem. I didn't get
What
it.
is overfitting and
Okay, what is overfitting and
underfitting?
underfitting, right?
Yeah.
Okay. Let me. I don't know if I can use a graph to explain. But okay, just understand this, right? Did you get the example of when teacher gave you past question to go and prepare for the exam? You now cram the entire question. Is it not? Any
Yes.
question that comes from that past question, you are going to get 100 over 100.
Yeah.
Very high score, is it not? Because you have trained with that past question very well.
Yeah.
You now came to do the test, is it not? You now came to do the test. Okay? Now say there's continual assessment. We're going to give you a test. He now gave you the test. But because not all the question was verbatim from that past question, they changed certain things. Is it not? You started what? Failing. But if they had asked you question from that past question, you would have gotten it very high score. But because they had modified it and it was not exactly the same, you were not able to what? Get it. Is that not it? So that is what they refer to as what? Overfitting. It's referred to as what? Overfitting. Overfitting. Okay? Which means if you look at the graph like this, everything they are giving you, you got it very well. You got it very well. Anything on this thing, you get it, you read it very well. By the time they now give you test, see where your score is. You're either getting this. You see, it's very wide. You see, the variance is very wide. The variance is very wide. This is what you trained on. This is what they now give you as test. What we are scoring is way up. Was not even close to what they were asking you. You're answering another question, and that's it altogether. So this is what they call what? High, they say high what? Variance. Okay? And this concept is referred to as what? Overfitting. And what does it simply mean? That when you look at the data on the trained data, you are going to what? Predict very well. Anything they give you within that trained data, the model will get it very well because it has trained it, it has crammed it. But when they give it new data or the test data to now predict, it's not performing very well. It doesn't remember it very well. Okay? So that's what they refer to as what? Problem of what? Overfitting. Problem of what? Overfitting. Underfitting means that this is what you expected. You were not getting it very well. You were not getting it very well. But it's clues. You were not getting it very well, but they are clues. But when they ask you any question, you're also getting it very close. Can you see that? Very close. So this is what they call what? Underfitting. It's called what? Underfitting. Okay. So the challenge is that your model may be say predicting it very high, but when you now subject it to live data, it doesn't perform very well. So that's what we call problem of what? Overfitting. I don't know if that answers you. Did we get it?
Yes, sir. So I get the overfitting. But for the underfitting, yes, you are describing a situation where it does not work properly with
Yes,
the test
in the
data.
train set doesn't work properly. But in
In
the
the
test
train
set,
data.
yes,
but
in
in
the
the
train
test.
data doesn't get it very well. But in the test
Okay.
data, it gets it very well.
All right, sir.
That's underfitting. So what you want a balance, is it not? You want a balance so that it's not overfit and it's not what? Underfit, is it not? It's not overfitting and it's not what? Underfitting. Okay. So what we call that is like look at it. There are like two extremes. You have what? Overfit and what? Underfit. So you want a balance here. It's not what you call maybe like a sweet spot. like a sweet spot, so that it's not over cramming it. Anytime it predicts it properly, when you give the new data set, it also predicts it very well. So that's the balance you want, which implies low variance and also what? Low bias. It has what? Low what? Bias. Okay, so that's what they call what? Your sweet spot. Okay, so it's as a result of this problem of overfitting that gave rise to the other regression. What do we call it? Your ridge regression, your lasso regression, and your what? Elastic regression. So they now take care of this low variance, and they take care of that high variance you get here, and the what? High bias you may get. So they try to what? Reduce the low bias and reduce what? The low what? Variance. So they are just like mathematical explanation for it. But they all come from what? Your linear regression. That's just the point I want to make to you. So once we have got that, so I hope it's understood why we need to what? Do train and test. Is it clear why we need to do train and test?
Yes, sir.
Good. So what do we do? So from the libraries now, so we now need to bring in the library. So what's the library? sklearn, is it not? sklearn dot what? Model selection. You see, we now need to select the model. Which model are we going to select now? For now, there's one we are going to do first. We need to first of all bring in what? The train test split. Train, test, and split. You know, from there, what do we do? We now assign what is my train data, what is my what? Test data, what is my what? Y train, that's my target train, and my what? Target what? Test. Remember, anything you do for the train, you must do for the test. Okay, what do we do next? We need to do what? Train, test, split. Okay, so how do we train it? So if I have my data set, maybe I have a sample of about 500 or 5,000. I will have to break this data into two. Train and what? Test. So to what extent are we going to train it? How many, what should we give it? So either we use what? 80% for training, 20% for testing, or sometimes they say 75% for training, 25% for testing, or 70% for training, 30% for test. Which are the others to use? Which one do you want us to use?
80-20.
80-20, you know? So it means 80% will be trained, right? Now, what we are doing in Excel, remember what we are doing in Excel, we are using what? 100%. You know, the one we did in Excel, is it not? We use the entire data, that's what? 100%. Do you see that? That is why when we try to do prediction, it will predict it as close as possible, is it not? Until we give it a new data to now know whether that model is what? Overfit or what? Underfit. Okay? But most times, it usually gives problem of what? Overfitting. Because it has seen the entire data. So anyone you give it to it, it will predict it correctly. But that's where the overfitting is. So that is why we now have to break it. So we're going to use what? 80 what? 20. 80, 20. So let's go. So here we are going to say y. You know what y represents?
The target.
The target. You know, so I will need to tell it, please, what is my y in this case? What is my y here? What is my y here? In this table. What is my y? In this data now.
Price.
It's price. You know, that's our price. You know, that's our price. And what's our x? What's our x? What's our x? Everything except what? Price. Is that not it? Everything except what? Price. So can you see that when I run X, you see only the features. Why when I run Y is only what? The target. I hope you understand that now. So that's our X and Y. Clear? Then we now say test size. What's our test size? What do you say our test size is? We are using what? 80, 20, not? So it means
Yeah.
our is going to be what? 20. Our train is going to be what? 80. Then, if we want to get exactly the same thing and do so, we can use what they call random state. So random state means that if I use 100 and use 100, you will get exactly the same random data I'm getting. Because normally random data will give you any data. Okay? But if I use a particular random state, means if I use random state of 1, it means pick any random state. If I use 1, the same data I will get randomly, the same data you get randomly. So that's what we call random states. Okay, so we have run that. So if I run what? X train, now what do you think will happen? If I run X train, what will happen? You see that I speak the data randomly. Can you see that? If you use exactly the same thing, you are going to get the same data set I'm getting like this. Then if I use Y test, you see another one again. Then if I use what? Y train, you can see there. If I use Y test, you can see there. Can you see that now? So Y train, so we have split the data into train and what? Test. Are we clear up to this point now? Because this is the same thing we're going to apply in the next what? Algorithm. The same thing. So what's next thing we're going to do now? What's next thing we're going to do? We are going to what? Train the model, is not? We are going to what? Train the model. So when you say you are training the model, what does it mean? When you say you are training the model, what does it mean? When you say you are training the model, what does that mean?
I think it's like practicing with it.
Training is not, you are applying the algorithm, is not? You are
Yeah.
saying applying algorithm. Apply the appropriate algorithm. You know, in this case, which is the appropriate algorithm here? Which is the appropriate algorithm for this our model? Which is the appropriate algorithm for our model?
Multiple regression.
Linear regression, is it not? So we say from sklearn, right? We are going to bring in what? Linear what? Model, right? So we are going to import. So we are going to import what? Linear what? Regression. And remember, because Python is extremely case sensitive, if I want to use lowercase, it will give me error. Okay. So now we have brought what? Now we have brought the linear regression, right? So what do we do now? We are going to what? Run it. Not. We are going to run it now. So let's call it linear model, right? So let's call it linear model equal to linear regression. You know what we are doing here? It means this is the more anytime I hear linear regression, I will represent it with what? LM. That's what we are saying. So instead of me writing linear regression, I'll just use this LM. Is that okay? So that's what they call creating an instance. Okay. So what do we do now? We want to train it now. Say lm.fit. What do you mean by fit? When you say lm.fit, what do you mean by fit? Remember that our line of best fit. When we are drawing the star like this, do you remember this line? So if you have all the star, you are now drawing a line across it. What you are doing is called fitting. You are fitting the model. Okay, so that's exactly what we are doing here. We want to now fit it. Okay, so how do we fit it? We are going to use what? The train and what? X train and what? Y train. Can you see that? So we have run the regression. So what you have done in your, what they call it now? Remember in Excel, what we ran it in Excel? It gave us our what? Intercept. Do you remember the intercept? LM dot what? Intercept. Can you see your intercept? And here's what? LM dot what? Coefficient. So this is your remember your Excel function, intercept. You remember it in Excel, your intercept function, it will give you the data there. Your slope function, remember your slope function? That's what you give you, that's what they call coefficients. But if you want to see the results, like the way it brings it out in Excel.
Yeah.
Hello? Somebody ask you a question.
No.
Okay. But if you want to see the results, the way you see it in your, what they call it now, you know how regression results comes out, right? You know how your regression comes out?
Yes, sir.
Going to give you arrow square and every other thing. So for you to do that, you have to bring in another library, okay? You have to bring in another what? Library for it. You have to bring in another library. So that library is called, I think, Start Model. I think it's Start Model. I think Start Model is the, this Start or Start, I can't remember. Either Start or Start Model as FM. Okay, it's Start Models. Start Model. Don't I always confuse whether it's Start Models or Start Models. It starts models. Okay. Okay. All right. Good. And to run the regression, so if you want to run the regression, just like the way you have it in your Excel, you are going to use the library called what? Start models. But the only difference here is that, you know, normally when you are writing your model, is A plus BX, maybe B1 B plus B2 X2 plus error 10. I hope you know what this is. What is A? What is A?
Intercept.
Intercept. What is B1, B2, B3? What are they?
Coefficients.
They are called what? Coefficients. Now, the limitation of this start model is that the limitation of this start model is that it does not include intercept in your model. That's the only limitation. So that is why you have to first of all bring in what? You have to first of all bring in the what? Intercept. So how do we do that? On that our X-ray data, if I run X-ray, can you see that? Can you see my X-ray data? There's no intercept here. Is it not? Is there an intercept here? Is there an intercept here? Is there any intercept here in this data here?
No.
No. So let me just call it X-trace, just a new, I want to call it a new name. So it will be sm.that start model dot add constants. And what constant am I adding to? I'm adding to my what? X-trace. Okay. So if I run X-trace now, can you see the constant there? So that constant is this our A. All these are our X1, X2, X3, and the rest. These are our what? Average income, age, room. So that's what you have there. Okay. So now we can now run it. So maybe I'll just call this one model equals to what? sm.ols. What does OLS stand for? Ordinary least square technique. So what you have been calling linear regression falls under the category of called ordinary least square technique. They are called ordinary least square technique. So this is why what we have been doing in the past was data analytics. Where we are going to now is referred to as what? Data science. So that's why you see that your mathematical and statistical skill was, as a data scientist, way more than what a data analyst. A data analyst can just know the basic ones. But for data science, it's a bit more advanced. It's a bit more advanced. So that's why most of you are now hearing most of these technical names. Okay, so it's called OLS. OLS stands for what? ordinary least square regression. All right. So the same way we have our what? Y train and we have our what? X trains. Okay. X trains. So if I run my model, this thing that has happened here is the same thing that what happened here. So it means we have run it already. So for you to see the result, what do you need to do? For you to see what you need to fit, so I can just say result equals to what? Model dot what fits. Model dot fit. So my result should be inside here. My result should be inside here. But for me to bring out the full result, I'll just say result dot summary. Now can you see the full result? Is it not how you saw it in Excel? Is this not how you saw it in Excel?
Yes, sir.
Good. And I believe that most of us should be able to interpret this result as it is. Can we interpret it?
Yes, sir.
So if I want to read it, I'll just check what's the predictive power of the model. 0.91, which is what 91%. Is that high or low? It's high, That's high. Of the variables, which is the most significant? Of the variables, which is most significant?
Number of
Not
bedrooms.
significant. How do we know if it's significant or not significant?
0.5.
Exactly. Once this p value is less than 0.05, it means it what? Significant. So which ones are significant? Significant, 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 not significant, and significant. So as a real estate agent now, does this model make sense to you? Is anybody real estate? Does this make sense to you? That the income area, the average income of the people in that area, the average house age of the area, whether it's new or old, the number of rooms, and the size of that population will determine the price. Does that make sense? Would that make
No.
sense?
No.
Number of bedroom too will determine the price.
Number of bedroom can determine the price, right? But it's not,
Yes.
not significant. So why is that so? Why is that so? What is the possible explanation why, based on this data set, number of bedrooms does not determine the price? Or is not significant enough in explaining the price? Why is that so? So imagine in an estate, they all have 3 bedrooms. The estate was just built all 3 bedrooms. So will it make any difference at that point? Would number of not matter?
No.
Because it's all the same, is it not? 3, 4,
Yeah.
almost the same, is it not? But if in a place where it may be 1, 2, 10, 5, then in that way there's a lot of variability, then it may what? Make a difference. But that's where exactly now you as a real estate person with that domain knowledge, with your experience in real estate, you can now what? Give interpretation to why. But if you still want to include it in your model, you can include it in your model. But if you want to remove any variable from your model, it is those variables that are not significant you will take out. All right. I hope this is clear.
Yes, sir.
So it means if I want to do a prediction now, how do I predict? Remember when we did in Excel, we had a sales as a function of what? Advert, isn't it? We got our intercept maybe as 13 point something plus maybe 28 point something, maybe 28.5. Then we now say if advert for next year is about 10, what will be sales? So we now apply this model to it, to now do our what? Prediction or forecast. Is that how we did it in Excel? That is exactly the same way you are going to build it here. Okay. First of all, C, let's see be our intercept. LM dot what? Intercept. So remember that our C is our intercept, right? So these are our intercepts here. Then our coefficients. So it means if I want to design a model to predict price, what do I do? I can now define it. Define, maybe I'll call it a rent predictor. What are the variables now? What are the variables I can bring in now? I can bring in income, age. I can bring income, age, rooms, private population. But if you want to bring in everything, that's also fine, right? But if you are bringing only the ones that are significant, then that's also okay. So it all depends on what you want. So which one did we bring in now? Except bedroom, right? All of them except what? Bedroom. So let me just call it income, age of the place, let's say rooms, let's say number of bedrooms, then let's say maybe the area, population area, let's say population area. Okay, so those are the variables now, right? Now what's the model? So the model is going to be now price, C the constant, plus the coefficient. What was our coefficients? Can you see our coefficients here? What do we have here as coefficients? We have what? So income was what? 21 point what?
378.
378 times what?
28. No.
Times the income, that's income level, whatever it is.
Yeah.
What?
Error.
If we break it down, here will be what? Plus 0.05. What would that give us now? If we multiply that, what would that give us? What would that give us? Now, let's say, for example, if I have to convert it now, if I have to convert it, right? If I have to convert it, you see all these coefficients, you see those are our coefficients, right? If I want to bring it out in full, now you see the data here. That means if I want to try and bring it in full, it means I have to put it like in a data frame. You have to put it in like a data frame just to be able to see it. But if you are not going to do that, then you can leave it. So do you want us to put in a data frame, or I should leave it? But if I have to put in a data frame now, let's say, for example, let me call it, what should I call it now? What should I call it now? Okay, let me just call it coefficient. Let me call it coefficient. Right, so let's say PD dot data frame. For those of us who did not join us when we started Python, sorry. So LM dot coefficient. What will be the column names? Columns will be what? What are columns? So let me bring in all these ones as columns. Bring in all these except price. I think all those are our columns now, you know. So probably let me please. All I'm doing is just to bring them as column names. Okay, so let me run 12 now and see. Aha, so can you see it now? Can we see how we have done it now? We have put it in. So now we can read this. So this is what I can just copy this out, copy it so I can get the exact thing. Times what? Times what? Age plus what? Number of rooms times what? These are these rooms, right? Plus bedrooms times what? B rooms plus what? The population size. Times what? Area. Are we seeing that now? So what are we going to do next? When you are trying to build the function yourself.
Return price.
What's the next thing we are going to do?
Return price.
We are going to return, right? Return. Return what? Price. Return price. I hope I don't make any mistake. Check. So rent. So the name of our function is called rent predictor, right? Rent predictor. So now, if I want to now predict, if I want to do any prediction now, so if I want to do any prediction now, what do I do now? If I want to do a prediction now, what would I do? If I want to do a prediction now, what do I do? I'll call the name. What's the name of my this thing? Rent predictor. That's the name of my function now. Rent predictor. Is it not? So I'll just put values there. So what values can we put now? So in terms of income level, what should we put? Income level, what should we put? Remember, let's run the X train. Let's do X train so that you just have an idea of the range, the price range. So put any price range within this range. What do we have within this range? Let's say we put what? Let's say we put what? Let's say put what? Let's say 60,000. Let's say 60,000. 60,000. Okay. Then house age. What should we put for the house age? Maybe 5 years, isn't it? Number of rooms. How many rooms should we put? So we have 6, 7, 5. So let's put what? How many rooms? Maybe about 6 rooms. Right? Okay, number of rooms. So number of rooms and number of bedrooms are they the same thing? Okay, number of bedrooms.
No.
Okay, let's put 4 bedrooms. The population area, let's say about maybe 40,000 or whatever. Okay. So based on that, can you see the prediction now? It's now what to do what the prediction for you. Okay, you now do what. So that's how actually you what check it. But you know, normally before you even implement this to now check, right? You actually have to also test. You know there's a train and test, right? You know there's a train and test.
Yes.
Right? You know there's a train and test. You know the first one we have done, we have trained it. You know, we have not tested it now. You know we have trained. If I do Y train, this data we used to train. If I say Y test, this is the actual. But we want to now what use that model to see whether it can predict this exact one for us. So that's now called what? The prediction. Okay. So to do that, we can easily what? Maybe I can just even plot a chart. Either we can plot a chart or we can just run it straight. I don't know which one we should do. So if I want to do my prediction, let me call it prediction. Because before you do anything, you have to first of all test it, you know. So it will be lm dot what? Predicts. What am I predicting? The X, the S test. So now if I do my prediction now, so look at my prediction now. Remember, this S test has not seen the model, we have not seen the data. Our model has not seen the data, so it has done the prediction. So now what do? We need to now compare that our Y, is it not? That's our Y, because this is what it's going to predict for. Okay, we are going to now, that's now done, that's your X test, that's now what predicted for you. This is what you have here. So that's our Y, which is our Y test. Let us now compare it, whether it is going to predict exactly the same thing or not. And remember, when you are predicting, it's just what an estimate. It's just what an estimate. Okay? It's just what an estimate. But if you want to put it in normal data frame, in your normal data frame, I can just call it maybe, what should I call it? Maybe I just call it P. Let's say PD.data frame. So we can see it like normal table. So I just call it maybe predictions. Predictions. Then my columns, let me call it what? Predicted price. Let's call it predicted price. You know this predicted price, our predicted Y. Predicted price. What do you say? Prediction. What do I use? Prediction. 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 All right, good. So if I run B now, can I see the predicted price now? Can I see the predicted price? Remember, we also have our what? Actual, which are our what? Y what? Test. Y test, not. These are our what? Y test. So if I want to bring them side by side, so if you want to see side by side, which means I want to bring the two of them together. Let me call it C, maybe like compare. So it will be PD dot what? Concat. What am I comparing? My what? What am I comparing? My actual, that's my Y test with what?
Y predicted.
My Y predicted, which is my B, is it not? My B. And because in code I cannot say x is equal to 1. So if I run it, see, can you see that? Can you see what that's done? Now, if I want to put it on the chart, so it's just like comparing, but you see some, it did not predict it. It did not predict them. Okay? So if I want to compare it on the chart, so just to see the ones that are predicted, take note, these values are large, so it's not all of them you are going to see here. So if I want to put it on the chart to see whether it predicted them in the same line, so I can use what? I can use what? A scatter chart. So my Y test and my what? Prediction. Now you see all those empty ones, that's what you are seeing here, blank. But this is what you are seeing, is now putting them together. Can we rely on this going forward? This relationship going forward?
Yes, we can.
Can we rely on this relationship going forward? Can we rely on this relationship going forward?
Yes, we can.
Yes? No? That is why to test, you don't have to what? Evaluate. Right? So you don't have to what? Evaluate your model, how well it is what? Performing. Okay? And there are different ways of what? Evaluating. So if I have run different models, the one with the least error, you know what you are trying to do is that error, you are trying to what? Minimize the error. Okay? So that's why we have about we have what they call mean absolute error. We have another one called mean sum of square error. And you have another one called, I think, root mean square error. Okay? You have another one, root mean square error. Maybe I'll just run one just to show you how to do one of them. Okay? So if I want to run it now, I have to bring in from which library is that now? I think from sklearn. Still from my sklearn, I will have to what? Import metrics. We have to import what? Metrics. Based on these metrics, we now have to bring in that mean absolute. So if I want to do the mean absolute square error, then what I can do to be what? Metrics dot what? Mean absolute error. So what am I testing? I'm testing my what? Y test with what? The prediction. That's the value. Okay, so that's the value for it. If I wanted to do another one, let's say for example, I wanted to do mean squared error. So here I'll just change here to what? Mean squared error. Mean squared error. I'll run that. Because they are all explained in different ways. So when you are comparing, you use one and compare against another model. You can this error itself on its own does not make any sense. Unless I now run another model, for example, if I run another model now, and in this case I now remove number of rooms, I run the model again. I can now compare. Should I use this model or use the second model without the number of rooms? Because it was not significant. Whichever one gives me the least error is the one I will go for. It is based on that I will now what? Deploy. Then they can either build it in form of a mobile app or in form of a website. So it now be called maybe rental price predictors. So what do you now do? You just put bedroom. So what we did here, what we have done here is now what you are calling deployment. You now put it in form of a website or in a mobile app. So you know, like all these services like property, what do you call them now? The private property. Which are these websites that usually check for properties? Which are those websites that you normally check for properties?
Property Pro.
Eh?
Property Pro.
Property Pro, beautiful, like Property Pro. So like for them now, right? You know, there are some search things, they'll put some criteria to search. Let me see. Let's see if we can get. Let me see if I can share one with those. Okay, property. You said Property Pro, right?
Yes, sir.
Property Pro. Let's see Property Pro. So let's say it's rents, right? So let's say it's rents. Am I sharing my screen?
Yes, sir.
Yeah.
So location is there. Let's say my location is, and I say okay, set. Now can you see the criteria? So you can see the variables. Where are the variables now? You see location, rent, state, type. Can you see that? Beds, minimum price, maximum price. Can you see that? Whether it's service or this. Can you see that? So based on this, all these are called my what? Features. Can you see that? All these are called your what? Features. So if you want to build a machine learning model for them, it means that what? You will need data of all the prices from all these places, you know, whether it is rent, short let, or sale. But for now, if it's just rent we are interested in, so we'll pick data for all the rents. Then, based on the various states, then based on the type they want, whether it's shop, office, house, we'll pick out the data. Then, number of bed space. Can you see that? Number of bed space. So if, for example, it's flat and apartments with all these bed space, minimum price can be any price, service or furnished. I will now run it. Based on that, we now use that to now predict what the price. Can you see that? So all these are now called our what? Features. Can you see a typical use case where you can apply it for like a real estate? So they are now called what? The features. So you have to now try till you get the best. Because remember, they are just estimations. They are just what? Estimations. I hope this is clear. So probably what will come next week, we will do the classification part of it. But this is how to normally do your normal regression. Is this okay?
Yes, sir.
Is this
Yes, sir.
okay? All
Yes,
right.
sir.
Yes, sir.
So please just try and practice. Because this is exactly the same thing we did in Excel, but the only difference that we had in Excel is that you see everything here, we have to build everything one by one. We have to bring everything one after the other. But in Excel, we're just clicking. These times you just click the cell. These times you just click the cell. This time you just click the cell. Okay. But with program, it's a bit more flexible. It's a bit much more flexible. But it's after you have done it and you have said, okay, this is the best model I'm taking. That's where you can now go and work, deploy it. So that's the deployment stage. So that's how you actually apply it in the real world. All right, guys, let me quickly join on that session now, okay? So we'll see you next week. So next week we shall start with logistic regression. I think we should end by the next week. We can't finish that next week or about week. But go and practice this one again. Because we're going to build on it. All right, thank you very much. And enjoy.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Bye.